So today's lesson, we're looking at the cosine rule. Now the cosine rule is not the cos ratio. Remember, cos theta equals adjacent over hypotenuse. That was for a right angled triangle. This is for a non-right angled triangle. So if you're looking at that triangle in front of you, where the angles are A, B and C, all in capital letters, again, side B is across from angle B. Side C is across from angle C. Side A is across from angle A. So how do we know when to use the cosine rule rather than perhaps the sine rule, which we've just looked at? Well, one of the surefire ways is here when we have two sides and their shared angle, so the angle between them. If we have that, then it's a surefire that we use the cosine rule. So what is the cosine rule? Well, here's one version of it. A squared is equal to B squared plus C squared, so the other two sides, minus 2bc, so those two sides multiplied together by 2, cos of A. Well, we were looking for A squared, cos of A. Let's see another version when we have our B as the actual subject. So B squared is equal to A squared plus C squared. So the other two sides squared and added together, minus 2 times those two sides, so 2 times A times C, times cos of angle. Well, we were looking for side B, so it's cos of angle B. And then the last one, where we make C the subject, C squared. So obviously it's the other two sides, which is A squared plus B squared. Can you see the pattern now? Minus 2 times A times B, cos of angle C. Now, it's not that you have to remember it, but it is a good idea if you can see the patterns there. Now, they are all the same rule. It just depends on what you are looking for. So these rules are good for when we're finding a side length. What about if we wanted to find an angle? Well, here's those rules rearranged. So I'm going to write them out for you so that you don't have to do it yourself. So let's take the first rule there and make cos A the subject. So how do I do that? I've got B squared plus C squared, and I'm going to take A squared away from it, and I'm going to then divide by 2bc. That is the first one. The second one, we're making cos B the subject. So in this case, it's A squared plus C squared, take away B squared, all divided by 2ac. Now, you don't need to remember these, but you do need to be able to use them. And the last one here, making cos C the subject, we have A squared plus B squared minus C squared, all divided by 2ab. So in this first example here, it says find C, side C, in fact, correct 2 decimal places. Now let's write out all of the information that we have to start off with. So we have side A, we have side B, we're looking for side C, and we have angle C. So I'm going to write that down, and I've got side A is equal to 34, angle A I don't need, side B is equal to 27, angle B, again, I don't need or want. I've got side C is what I am looking for, so that is my unknown, and angle C is equal to 50 degrees. Now you can see there, when I look at it, I've got no pairs. When I was looking at the sine rule, I tried to pair things up, and if I could get 2 pairs where I had one unknown, then it was a surefire thing, it was the sine rule. I can't use the sine rule here. But what I do have is two sides and the shared angle. I have side A and side B and the shared angle. So I'm looking for side C. Let's write our rule out again. C squared is equal to A squared plus B squared minus 2 times A times B times cos of C. Let's put in what we know. So we have 34 squared plus 27 squared minus. Now, I usually put this in a bracket when I put into my calculator. 2 times 34 times 27 times cos of 50 degrees. All right, that's what C squared is equal to. So obviously C is equal to the square root of all of that. So C is equal to the square root of 34 squared plus 27 squared minus 2 times 34 times 27 times cos of 50 degrees. Now all of that can go into your calculator in one hit, and what you should end up with to 2 decimal places is 26.55. Now in the next example, the question asks us to find the largest angle. Well, how do we know which one is the largest angle? Well, quite simply, the largest angle is directly across from the largest side. So what is my largest side? It is 6. So my largest angle would be angle A. So what do I have here? I have side A, I have side B, I have side C, and I'm looking for angle A. So A is equal to 6. Angle A is what I am looking for. Side B is equal to 4, and angle B I don't know and I don't want. Side C is equal to 5. Angle C, again, I don't know and I don't want it. Again, you can see it can't be the sine rule that we use. I don't have 2 pairs where I've got one unknown, so I can't pair them up there. But what I do have is 2 sides, so side B and side C, and I'm looking for angle A. So remember, I'm looking for angle A, which means that cos of A is what I'm looking for. What does cos of A equal again? It's equal to B squared plus C squared minus A squared. Go back and have a look at your rules. You do not have to remember these by heart. Divided by 2BC. Let's put in our information there. So you get 4 squared plus 5 squared minus 6 squared, all divided by 2 times 4 times 5. Now that's what cos of A is equal to. What do I want? I want A. So obviously A is going to be the inverse cos of the above. So let's put that into our calculator, and when you work that one out, you end up with A being equal to 82.8, because we want it to 1 decimal place. So 82.8 degrees. Now, if you're not getting that answer, you're getting a strange answer, your calculator may not be in degrees. So again, check to make sure your calculator is in degrees. So in this last example, we have got 2 bushwalkers both leaving from base camp, which is there. The first one goes 10 kilometres to point B up here on a bearing of 070 degrees. Now remember, that's a true bearing. It starts from the north and goes in a clockwise direction. So that's why that is 70 degrees. The next bushwalker starts at base camp again. This time walks 8 kilometres to point C on a bearing of 120 degrees, which is that bearing there. So obviously this little bit in here must be 60 degrees, because we know that all of the angles on a straight line add up to 180 degrees. There's your straight line. So therefore, we want to find what? We want to find the angle between their paths, which is this angle in here. Well, that's relatively easy, because as we just said, that all the angles on a straight line add up to 180 degrees. So we've got 70 degrees plus A plus 60 degrees should all equal 180 degrees. Now that's a fairly simple equation to solve. Bring the 70 and the 60 over the other side, and what do you end up with? You end up with 180, take away 70, take away 60 is 50 degrees. So that is part one. Part two, we're asked what? How far apart are the bushwalkers when they stopped walking? Well, they stopped walking at B and C, so obviously we want to find this distance here. Well, let's have a really good look at our triangle here, and let's see what sort of information we actually have. We now know that we are looking for side A. A is what you're looking for. And we have angle A is equal to 50 degrees, because we've just worked that angle out. What else do we know here? Well, we have side B, because it's directly across from angle B. Side B is equal to 8 kilometres. Do we know angle B? No. Do we need to know angle B? No. Side C, again, directly across from angle C. Side C is 10, and angle C we don't know and we don't need to know. Again, we cannot use the sine rule there. We don't have the pairs. So it has to be the cosine rule. Cosine rule, we are looking for side A. So what is that rule? Can you remember? If you can't, don't try. Make sure you go back and have a look. So A squared is equal to B squared plus C squared minus 2BC cos of angle A. All right, let's put all that information in, and you get 8 squared plus 10 squared minus, now again I like to put the bracket, 2 times 8 times 10 times cos of 50 degrees. All right, that's what A squared is. A is equal to the square root of all of that, so 8 squared plus 10 squared minus 2 times 8 times 10 times cos of 50 degrees. That should all go into your calculator in one hit. And when you do that, you get 7.82 kilometres, because we want our answer correct to 2 decimal places. So 7.82 kilometres. Just checking, make sure that your calculator is set in degrees. That could be one of the reasons that you're not getting the right answers there. So that is the cosine rule.